It's about net rainfall estimation by inverted geomorphology based unit hydrograph in Tunisian cave. The main idea of this work is the use of a geomorphology based unit hydrograph in a semi-arid basin localized in central Tunisia. So in this work we use a transfer function based on geomorphology hydrograph, which is calculated as a probability density function based on the calculation of length of stream course and an average velocity. And the first calibration of this model was on the basin, Srila basin, which is presented here. It's about 192 square kilometers, part of the Mergellil Central Tunisia basin. So this work is based on the inversion of the transfer function by the use of inverse modeling. So the net rainfall is the major parameter. The parameter calculated or of interest is the net rainfall, which is defined as what we collect from the hill slope to which is enters to the our network. So this net rainfall is calculated by this formula. It's the solution of the maximum likelihood solution, and with a matrix of partial differential of the model and some covariance matrices. Here is some examples. An example of this event, first event. So here we are initializing the model by two a priori of simulation. The first a priori is calculated as the runoff coefficient by about the runoff coefficient, and the second a priori is estimated by the specific discharge. Of course, there's some lag time which is taken into account. So with comparing to the results, we can see that for with the first initialization, we have a Nash criterion about 0.96, and the second is about 0.98. So we can see the approximative. So the two approaches are almost gives almost the same results. So it's the same. To conclude this part of the work, we can say that this presents a low instrumental and engaged basin methods, and this doesn't need a production function, and it's opening several perspectives, such as the transposition from one to other basins by using the calculated rainfall and other which is transposed for other basins, and it's also a technique to reflect or to find some production function for the base, for hill slope. So it's a robust method, and which is based on a simpler function.
Thank you.
My name is Boudhraa, and I'm going to present work on disaggregating the impact of hill slope changes by geomorphology-based deconvolution of outlet observation. This work is based on the inversion methodology based on geomorphology unit hydrograph. In this work, we use the same method of the inverse transfer function, and we use a basin, a small basin, which is for which we have measures. We have some hill slope management, and for those we have just before and we have data just before and after this management. So the basin transfer function is looking like that, and using this method, we have studied some parameters on the some production indicators that we identify, and we look about the counter ridges impact. The counter ridge as the management, the only management. We can see here an example of a counter ridge on this basin. So for this basin, this counter ridge are steadily implemented during summers 96 and 97 on just one year. So we have existing data before and after implementation of these counter ridges. The application of this method shows various significant changes in the hill slope scale, which we are not appearing on the basin level for the rainfall runoff process. So we can see here some examples of 11 pre-implementation events, and nine events post implementation. And we can see, looking to these results, to the impact of these counter ridges. We can see diminution of the coefficient, runoff coefficient, about 4 times, existence of a threshold for production, and also added mean production delay due to this counter ridge. So, as conclusion, this method presents a robust and generic geomorphology-based transfer function, which is assumed to be stationary through time, since changes occurred on hill slope and not in streams. And it's a promising impact assessment method for downstream, and as an alternative to upscaling and aggregating hill slope approaches in catchment where we have a sudden change.